Remco Timmermans. It's a pleasure to have you on. So I've known you from Space Up and from what you're doing with Powering Space now, trying to drive and market the UK space industry. But perhaps you want to introduce yourself to everybody out there.
Sure. Be happy to. Well, thanks for having me, Adam. Always a pleasure to have a little chat. So yeah, I'm Remco Timmermans. I live in Harwell. Most of you should be familiar with the place. I have my home office there. I have my own company. Basically, I'm one of the very few marketing agencies in the world specializing purely on the space industry. I do that all over the world from my home base here in Harwell. In addition to that, I'm affiliated to the International Space University as a member of faculty, and I do guest lectures there, mostly focused on space management, business communication. And I am one of the directors of Powering Space, which is a new new organization with 5 co-founders that is trying to bring together a community of space communicators, space outreach specialists, space marketeers, or anyone communicating to their respective audiences about space, just to create some sort of a community of interest, bring together knowledge, do knowledge sharing, and basically get to know each other a little bit better, because we are we have been quite an unorganized group, and looking at the relevance of space outreach, it's good to bring us together and maybe learn from each other.
I agree 100%. I think if there's one thing the UK has been lacking, it is a cohesive kind of body that is bringing together all the learnings for all these different businesses.
No, absolutely. And it's not just the UK. I mean, we have a focus on the entire world, because the UK is, compared to many other places in the world, is actually doing relatively well.
Yeah, it's doing a lot better. It's doing a lot better now.
Yeah.
I guess my question is, like, well, where do you see the space industry right now globally? Because there's been, since Supernova Labs has started, which is about 5 years ago, I've seen enormous growth in how many countries are trying to get involved. There's maybe some more tension between big players in the world. The UK seems to want quite a big stake, doesn't quite know how to get that yet. It's doing it. It's got burgeoning stuff going on. Mm-hmm. Luxembourg seems to be just full stamp on the accelerator. Let's just go. Yep. We're going to have a larger presence in space than we are going to have on Earth. So what's your view on all that?
Yeah, so you said there's a lot going on in the space industry in the world, and that's definitely true. We are seeing right now, and more so, the change from old space into new space, and we are now seeing new space becoming a thing in an increasing number of countries around the world, and more people jumping on the bandwagon because of the benefits of new space. I mean, new space, commercial space, is how should I say that, is really making space much more accessible to a much bigger group of people, with launch costs going down, with more and more technology becoming available, meaning affordable for many more organizations, but also for students and universities. And in fact, I think universities have been at the forefront of this by developing this CubeSat standard, for example, which has enabled a lot of people to get involved, to get their hands on space technology, but also the emergence of the availability of space data, of Earth observation data, of satellite navigation, even communication system. So there's a lot of opportunity out there, and with that, there's lots of support from governments, and that's the case here in the UK. That's the case in the US, from governments, but also private funders. There's money available because this business, this market is developing. In fact, space is growing at twice the rate, at least from a UK point of view, at twice the rate of the rest of the economy.
Right. I don't know
wherever
that. That's my primary industry.
Something I picked up at the space bar yesterday. We had a market analyst who said that space is, I think it was it was the European market, could have even been the global market. I don't know. I believe both, but that the space is accelerating and is growing at twice the rate of the normal economy. And that means there's demand, and where there's demand, there is people who are looking for opportunities to invest. So there is money, and that's really
so
important.
I've seen a bunch of companies start up. Like there's a one over in New Zealand that's kind of alongside Rocket Lab, but they're doing what's the name of this space plane again that they're building out there?
Oh gosh, there you asked me. I
Yeah, I know. It's just, but I'll link up their name above here. But they're doing a mail order service for rocket nozzles, like 3D printed rocket nozzles now. So you can just go onto their website and buy a rocket nozzle for a set price, pay for it there, and it'll be shipped to you. Like it's literally as easy.
Yeah, no, absolutely, and that's a clear example of what's going on. The commoditization of technology. I mean, yes, you'll be able very soon to build your own rocket in your shed and launch it from one of the many launch sites that we'll have available, especially here in the UK very soon.
Yeah, be like an upgrade to hobby rockets to
well,
like
in a way,
going down to the launch
and I mean that's probably an extreme example, but that's how it happened with satellites. I mean, everybody is now able to build a satellite right here in a room the size of my tiny little office. I can start building a CubeSat here, and I can buy all the components, literally all the components, off the shelf, and I can even book my launch online without leaving this room. I can have the whole thing ready for launch and integrated and launch it in a matter of months.
Well, this is the thing, because like over in the States, they have like a massive rocketry scene out there where they all go to the Nevada desert. They have like sort of 10-foot rockets that they're able to launch. And this is the hobby scene. This isn't even like the professional scene. And it's just interesting that whole thing is now spilling out over into other countries now.
Well, in a way, I mean, yes, hobby rocket. I mean, that's how rocketry started in the 1920s and 1930s. I mean, remember Werner von Braun? He was, even before he started to build these horrible weapons, he was one of the key rocketry club members in Germany, developing systems that ultimately led to, we know what it all led to, whether it's good or bad. But he started as a model rocketeer. And that's a great start for many. I mean, if you look at the rocketry clubs and universities, for example, they launch. Well, I don't know if you can even call them model rockets anymore. They launch pretty sophisticated stuff.
They're getting like several miles into the atmosphere.
Yeah, exactly.
Fascinating.
So again, that's a sign of the times, I guess. Is that this thing is taken out of the hobby scene. I mean, building a CubeSat was a hobby thing, but now I can actually have a very serious commercial satellite, building it right here on my desk, having it shipped to whatever launch site, and have it in space in a matter of months, and start running my little space business based on a satellite. And it's affordable. It's relatively affordable. I mean, I could probably still buy a house.
It was like 10K for like end-to-end like CubeSat. Like I think it was like a 1U CubeSat cost about 10 grand, like from end to end to launch.
Yeah, to launch it, yes, and then you need a little bit more to build it. But it's become very accessible, very affordable. That it even becomes within the realm of normal people like you and me to start building that. And if we team up and we team up a little bit of money, maybe find an investor. That investor doesn't need to invest millions anymore. The amounts involved are lower and lower. Now, of course, that comes with all kinds of other issues, like how many satellites can space sustain at the moment. But that's a whole different discussion. But
space junk, right? So this is one of the big things that we've been talking about is space junk, and how do you like? I mean, I was reading through a document from UNOSA yesterday, and it was going through like these are the terms that we're going to agree to about space junk, and it was all about we'll limit the amount of junk that's created from our work, and like we'll try and mitigate the stuff that's already up there. Absolutely no mention of we're going to start capture and retrieval of this junk, despite it being at a stage now where if it isn't sorted within the next 10 years, there'll be Kessler syndrome and certain orbits won't be accessible.
Yeah. Yeah, no, definitely a big issue. But again, this is and that's interesting about this particular issue. I mean, ANUSA has been struggling with space junk for a long time, discussing it in their copious meetings and trying to establish standards and norms that countries should adhere to. That obviously has only happened to a certain level because countries and players do whatever they want. But
Yeah,
now it's,
Russia, right?
I mean, yeah, just look at what Elon Musk is doing. I mean, is it legal? Yes. Is it moral? I don't know.
Well, I mean, I have Starbase Live streaming behind me right now. But I
Yeah,
guess
well,
this is happening in the context of the full stacking of Starship for the first time.
yeah, no, that's a great example of how Elon Musk is really accelerating certain developments. But at the same time, Elon Musk is also putting, what is it, 12,000 Starlink satellites in orbit, basically occupying the entire orbit and leaving no room for others. And again, is that legal? Yes, because he's complying with the FAA regulations and with other US regulations, but he is kind of ruining it for others. I mean, and then I'm not talking about the astronomers, but I'm talking about other countries or other actors who are looking for similar opportunities, and that will be increasingly difficult. And he's the first, so he can do it.
They are very forthcoming in terms of avoidance as well. Like, I mean, I've heard of a couple of stories where other places, like other countries, even they've had to move their hardware because they can't get in touch with SpaceX. They won't respond.
Yeah,
They're like, oh, we're about to have a collision.
Yeah, including the European Commission with their Sentinels. They've done a few avoidance maneuvers with
Really?
Starlink already. But
Blimey.
but yeah, I mean, and that is that's an interesting point. And UNUSA definitely has a role to play there in establishing, well, at least norms, because there's not much more than they can do than establish norms. But yeah, it would be good if some new form of governance would happen there. But at the same time, this is an opportunity for commercial players. We see here in the UK, well, it's a Japanese company, Astroscale, who is now, and they're not the only ones, but Astroscale is definitely one out there that is on the forefront of active space debris removal. And who are looking at it as a commercial opportunity.
So what have Astroscale done so far? Because I remember the last time I heard about them, they were going to do this like launch, like capture, well, release a piece of debris, try and like work out how to like navigate around it. But did that launch in the end?
A few things have happened, but I think the last that I heard, but I need to double check, and I probably shouldn't say that too hard in public, but the last launch they did occurred some kind of a mishap. Not a mishap, but some technical issues that I'm not sure whether they've solved it yet. But you know, that's how space works. That's how space has always worked, and they will overcome those technical difficulties. I mean, this is just the beginning of it. So yes, of course, they may run into a few challenges that they will solve, but the fact that they're looking at this and with them a few others looking at this as a commercial opportunity where they can do this as a service for governments or for satellite operators, that business model still has to flush out a little bit.
Well, I'm telling you, like I'm surprised that it hasn't kicked off. Well, I mean, maybe Astroscale will be the first one to trailblaze it, but there is money just on that hardware being on orbit. There is a lack of potential energy. A huge amount of potential energy. Sorry, already invested in that hardware. So, like, if you were to centralize it and bring it back to like centralized stations where you can reprocess it.
That's yet another opportunity. So you have the debris, either dysfunctional satellites that cannot be serviced or just pure debris that will have to be removed one way or another. But there's also the satellites that are reaching end of life that may be serviceable. And at least the latest generations of satellites, people are now starting to think about the serviceability of those things. Yeah, that they can be refueled.
There have been a couple of things where people have bolted on a additional tank and engine to defunct satellites.
Yeah, exactly, and that is a very clear business model, because if you can extend the life of communication satellites or TV broadband satellites with a few years, there's serious money involved there. And yeah, no, there's several companies who are trying to do the refueling or other forms of servicing in space, rather than just deorbiting them or putting them into graveyard orbits. It's interesting that also I read last week, I don't know the details, but that the Chinese have done that with one of their communication satellites. They sent
Oh,
a
really?
spacecraft into the geo belt and used the spacecraft to push one satellite out of the way and parked another one there. And yeah, that's really the future. If these satellites can't move out the way themselves,
What a
and many of them
fascinating
can, but
thing.
not all of them, is yes, you can have spacecraft just to push them into the graveyard orbit to
I wonder if there's
free
something
up
in
that
there
spot
where it's
for
like
another
going to
one.
be people like jostling for space, like
Yeah, well, literally, I mean,
do some
space looks big,
offensive
but
stuff. I'm going to move your satellite just out of the way.
yeah, but it makes perfect sense. If it's in LEO, you push it down. If it's in GEO, you push it up,
Yeah.
and it
So
will push it
I
out of the
think a
way.
lot of people forget about this. There's this graveyard orbit with like tens and tens of billions worth of hardware in it that's just like floating around dead.
Basically, yes, and it will stay there for hundreds of thousands, if not forever.
Yeah.
But yeah, but you know, many of these old systems, they've been built to last for 10, 15, 20 years, whatever their intended lifespan was, and when they're end of life, there is no way to service them, so they have to be pushed out the way, and that's a mentality that is now changing, where reusability, not just in launches but also in satellites, is becoming a topic, because you're absolutely right. There's billions invested, hundreds of billions invested in all those systems in space. Yeah, it would be a waste to just use them once.
Yeah. I've got a long-term vision for it where we go and capture an old Saturn V booster, and we're gonna hollow it out, clean it out, and set it up as a what do you call it? Either a platform or a space station itself.
Well, yeah, that's exactly what they did with. That's exactly what they did with Skylab.
Well,
I mean,
yeah,
that's
exactly.
how
That's
Skylab was
it.
built.
The way the Skylab was built was the tank for, is it the third
Basically,
stage?
yeah, it was an empty stage that they didn't need, because they didn't go to the moon with the Saturn rockets. They went to a low Earth orbit. That means they didn't need that much fuel, so they had like an empty stage.
Well,
That
there you
became
go.
the Skylab station.
And then there's all the work going on with inflatable volumes on the space station right now as well.
Yeah.
If there was some way of like putting an inflatable ball inside of one of these boosters, you then have a habitable volume.
Yeah, exactly. Yeah. I mean, we had this inflatable module builder. What was it called? I forgot the name of the company now. This American company, but they kind of went out of business. But they have a module attached to the ISS.
Really, they went out of business. Bigelow.
Yeah. Bigelow or Bigelow, whatever way you pronounce it.
I have no idea.
But yeah, they sort of went out of
one
business.
everybody's red. That's it.
But yeah, that's the idea. So it makes perfect sense. But all these things, they kind of signify a new era in space. And all these companies that we've talked about, they're all commercial companies. So they're not government driven, although many of them, and especially Astroscale, they will depend on government contracts to make a business model, because only governments at the moment will technically pay for space debris removal, because nobody feels responsible. At least no commercial player will feel responsible. So hopefully governments will feel some responsibility for that.
Well, there's a legal element to it as well. Like when it comes to on-space hardware, the stuff that's left up there, whether it's junk or otherwise, is still the responsibility of I think it's the launching government, or like the person whose flag has it on the side, basically.
Yeah, I'm not a space lawyer, so that's really for space lawyers to determine. But yeah, you're probably right. I have no idea whose responsibility it is, but yeah, it could be the launching state.
Yeah, I think I've spoken to a couple, and they've all said it's. I mean, a lot of space law at the minute is more like, well, how do we start defining this, instead of it being like this is clear cut. Yeah. But I think one of the things that have been is like more like coming towards consensus now is that the junk that's up there is the responsibility of the launching government,
right?
Not necessarily the launching party. So like a company could launch something, it goes wrong, they can kind of be like, oh, okay, but the country that launched it is still responsible for it.
Right. Yeah. So yeah, I don't know how far that extends to like defunct satellites, if they still carry the responsibility to take that out of orbit, because I don't think any space law existed for that particular
nothing for
purpose.
salvage.
But yeah, that business model will need to be developed. If active space debris removal will ever work, some legal framework will need to be built to see who is responsible and who is to be billable, if you like, for these commercial companies to build a business model around it. Yeah.
Fascinating. So Remco, like, you talked a little bit more. You talked a little bit about Earth observation before.
Yeah.
I just wanted to draw attention to that. What was that platform you showed everyone the other day?
Oh, what I showed, yeah, in the WhatsApp group. Well, it's not a secret at all. That's the Sentinel Hub, and Sentinel Hub is an Horizon 2020 project that was established to help make Copernicus data, Copernicus Earth observation data accessible. And one of the things that they developed is what they call the EO browser. And the EO browser is a very simple interface.
I mean, it's phenomenal.
Google Earth like or Google Maps like interface for Earth observation data for Copernicus, for all the Sentinel data, and not just that's the difference between that and Google Maps and Google Earth, which actually makes it much more interesting because it doesn't only have optical data; it also has all the other spectral bands available, and so you can look at particular places on Earth in all kinds of different wavelengths, and even using radar information and infrared measurements. It's really powerful.
I mean, it blows my mind. I mean, like I just had a look at it before, and I started like trying to work out how do I pull out a data set. It's not like that trivial to like draw out all the data, and there are like you can pay extra for specific data sets.
Yes, yeah, but that's how Copernicus works. So it's not just the Sentinels, which information is basically available for free, and Sentinel Hub, the EO browser, is a free tool, open. You don't even need an account. You can go in there. I mean, put the link in the video if you can.
Yeah, I definitely will,
because it's a great tool. But yes, it does also
it's like Google Maps,
provide
like,
an interface.
Yeah,
it also provides an interface to commercial data, and yes, you can buy that. So if you see a gap in what you're specifically looking for, whatever it is in your data, then commercial suppliers might be able to fill that gap for you.
Oh, interesting. You see, I've never thought about this. I've always wondered, like this really bugs me about Earth observation data, is that it's never really been clear to me like how people define a market for like, oh, I'm looking at this. Oh, I'm looking at, like, obviously there's a lot of different applications for specific customers, but in general, like, oh, okay, like, oh, I see a gap in this data set. Maybe then that's something I can fill.
Yeah, and that's how commercial Earth observation operators work, really. I mean, they look at those gaps. A good example is Sentinel 5P versus GHGSat.
Okay.
So Sentinel 5P is one of the satellites in the Copernicus program that specifically looks for greenhouse gases. So it measures NO2, it measures methane, but at a very coarse level. And in come this Canadian company called GHGSat, GHG for greenhouse gas satellites. They have satellites, several out there at the moment in similar orbits as the Sentinels, but with a much higher spatial resolution. And there's more than one. So where Sentinel 5 scans a very big area quite coarsely, but it can pinpoint certain sources of methane, for example. Methane emitters is a big interest area at the moment. Then GHGSat can pinpoint their satellites that have a much smaller area that they cover, but with a much higher spatial resolution, and they can measure methane down to the individual sources, and they work hand in hand. So many researchers use Sentinel 5P to scan a broad area for an emitter, and then once they found an emitter, they ask GHGSat, and they pay for that, to give them information of a much smaller specific area. And it's brilliant, and that's how it works, and that's the business model for GHGSat.
Well, I saw something as like one of the ways to tackle climate change would be to make polluting with methane, CO2 too expensive for the companies that are doing it, because at the minute it's far too cheap. And if for every dollar of like CO2 and methane people were putting into the atmosphere, it was ending up costing them $100 in litigation as a result of it, that would start to flip the script on the whole thing. So if there were data sources like this where, let's say, activists or people that are involved in the environmental movement can actually go and find like pinpoint data with historic. And the thing is, this is one of the things about this browser that blew my mind. It has historic data, so you can like almost like scrub like a timeline. Through
absolutely.
specific data sources.
Yeah, no, it's brilliant. Another good one is windy.com. Windy.com is a weather site, but they take in information on air pollution, also from the Copernicus satellites.
Oh, really?
And especially the nitrous oxide measurements. They're amazing. In the windy interface, kind of visualizes it in a very intuitive way, where you can, for example, see shipping lanes and see motorways in Europe under certain conditions. You can literally see where the motorways are, where the heavy industry is, and where the shipping lanes are.
That's the because things with a lot of these ships, they just burn straight crude. Like a lot of them, like it's like whatever's left after the cracking process goes into the ships.
They burn the wrong stuff, so they're very polluting, and that's it. That is improving a little bit, but no, that's what very few people realize. Everybody's looking at the airline industry for pollution, but the shipping industry is much worse.
Yeah, the thing is with the airline industry, it's like plain, it's super refined kerosene, so probably more efficient relative to other engine types.
Well, I did research in a previous life. I was a sustainable development researcher in tourism and hospitality, and one of the focus areas of my work was the cruise industry. And what many people don't realize is that cruising is the most polluting way of going on holiday. If you look purely at the CO2 emission per passenger kilometer in any vehicle, a cruise ship is the worst. People think, oh, if you fly to Miami and then get on a cruise ship, oh, that flight is terrible. I wish we didn't have to fly there. But the cruise itself is actually much more polluting.
I have no idea.
Per passenger kilometer than a plane.
Bloody hell, there's a lot.
And many people don't realize it. They think, oh, we're going on a cruise and we're going to.
Yeah, it's on a boat, right?
It's not fresh air.
Anything.
Yeah,
it's just powered by what do you call it? Unicorn farts and tinsel, right? So...
Yeah, it's crazy. Do you know how far a cruise ship sails on 1 liter of fuel?
Oh my goodness. I don't know. It's probably like very little.
It's about the width of my laptop.
Really? I was going to say like a meter.
This is how far they sail on 1 liter of fuel. 30 centimeters. Damn. Now imagine 1 liter of fuel in your car.
Way worse than a game. God damn.
Now they do carry 2,000 people, so you spread it over 2,000 people. But still, what people don't realize is that it's still more polluting in CO2 emission than the flight to whatever cruise port they're departing from. So don't go on a cruise.
Yeah, I know, right? I am never going on a cruise ever again, unless it's got big sails. But then you never know.
Yeah, sorry, it'll take you ages to go somewhere, but at least it's less polluting. But no, people don't realize. And if you look at which is the most polluted city in the UK, it includes a few, but Southampton is definitely in the top 3, and that's purely because of ships. It's not the city itself, but it's purely because of the ships. It's been calculated
there as well.
That if you look at the Southampton area, the cars that drive around in the county, in the metropolitan area of Southampton, all the cars that drive around there for a whole year are less polluting than the ships.
Really? Huh. Wow. I guess this is the thing, because have they got military bases in Southampton? Because
no, the Navy's in Portsmouth. It's just around the corner. Okay. But no, this is purely the port of Southampton, which is an oil port and a cargo port, and it's the biggest cruise port in the UK.
Oh, I didn't know. Huh, there you go. Learn something new every day. I know nothing about this country. But I guess maybe this is like I want to like come back to the UK industry in particular, because I feel like that's the one thing that's affecting us, both of us, most, considering it's our like primary base.
Yeah.
What do you think is going to happen with everything at the minute? Like, where do you see the future of UK industry? Like, what are the major projects that you see coming along? Like, what do you think they could be doing better? if say this somehow falls on the desk of the UK Space Agency officials, like what would you want them to know?
Yeah, well, first of all, what I'd like to say about the UK space industry is that it is one of the best ones in Europe. I mean, I'm not English, as you can maybe hear. I'm Dutch. I moved here 3 years ago from the Netherlands because what the Netherlands don't do is what the UK does, and that is stimulate the space industry. So for the Dutch government, the space industry is kind of secondary importance. It's there. We have, I mean, the Netherlands has the biggest ESA site in Estec in Noordwijk, but the investment of the Dutch government is how do I say that? The ESA contribution is always discussed, whether they should contribute to ESA at all. And it is the fact that Estec is there that kind of keeps the contribution at a level, but it's one of the lowest levels per inhabitant in Europe. So for the Dutch government, space is not a priority. And that's the same for many governments in Europe, but there's a few that are doing much better, and the UK is definitely one of them. I mean, you mentioned Luxembourg just a few minutes ago. It's another good example, and then more recent, but the UK is definitely there when it comes to looking at space. And what the UK said in 2017 when they presented their strategic space plan, whatever it's called, this government plan for the space industry. And I still saw it. Was it 2 weeks ago when we were in London for the Space to Connect event? It was still on the slides that the UK's objective is to capture 10% of the global space industry by 2030. Now we all know that by 2030, the global space industry might be a $1 trillion industry, a little bit less in pounds, but still $1 trillion industry. 10% of that is a lot of money.
Yeah, I never thought about it like that. Fair enough. I guess I'm always thinking about it like 10% of the industry as it stands.
No, it's 10% of the industry in 2030, and the industry will have grown by then. I think now we're talking about a 700 billion industry, $600 or $700 billion dollar industry at the moment, and that will grow to $1 trillion industry by 2030. And the UK wants to capture 10% of that. I think that's extremely ambitious, but I have to say that at least from my point of view, if I compare it to other European countries, the UK is actually working on that and is actually establishing.
They've definitely listened to people.
Yeah,
in the
they put their money where their mouth is, and you see that. You see new space centers popping up all over the country. We had the opening of Spaceport Leicester or Space Center. I don't even know what they call it, but the Space Hub in Leicester.
Yeah.
We see Scotland now promoting, Edinburgh and Glasgow being promoted as space cities of the north. We have Harwell here, of course, but we also have the universities in the south, in Southampton, lots of places in London. So the UK is definitely getting there.
I guess, like, just for people that maybe don't know anything about space, because I assume there will be people watching this that know a lot about space, that know us.
Oh, sorry, I was assuming all that. Yes,
but just because I remember being in that position where, like, I was sat here in Manchester. There was never really much going on. There was like one company that was kind of dealing in rockets, but was more doing education than anything.
Yeah.
Like, I had no idea where to go and like what was going on in different cities. What do you kind of see like happening in these different cities, and like how does that kind of map together as like different parts of the space industry?
Well, there's a few angles to this, and basically you should look at it from 2 points of view. There's what we call the upstream and the downstream. Those are two different parts of the space industry that have a very different focus. So the upstream part of the space industry is involved with technology, basically in getting stuff up. That's how I remember it. In building rockets, in building satellites, in building hardware, building infrastructure to support an infrastructure in space. So it's very much hardware technology focused. And there's the downstream that deals with everything that comes down from space. And I don't mean debris, but I mean data. So that's the Earth observation, satellite navigation, communication field. Now, both are very prominent in the UK. There seems to be a lot of focus, because that's the cool side of it, in the upstream side. So we see all the spaceports popping up. We see all these small launcher companies, Orbex, Skyrora. popping up. We see lots of companies working on space hardware. Yesterday in the space bar, we had Mark from McDrive. They're building micropropulsion units for small satellites.
Yeah,
and there's dozens of these companies that do that. We now have the first space company in Wales, in Cardiff. We have Spaceforge, who are building reusable satellite platforms. It's brilliant. There's a lot of focus on technology, and there's a lot of support in the form of, for example, the ESA Business Incubation Centers that provide a lot of support for those types of initiatives. There's money through the Satellite Applications Catapult System, Innovate UK, that has funds available for innovative technological solutions, and that is driving places like the Space Campus here in Harwell, which is very hardware focused. The new Space Center in Leicester, which focuses a lot on CubeSat technology, and this whole business incubation framework that we have. And then we have places that focus very much on downstream. So on space data applications, Edinburgh is promoting itself as the space data capital of Europe, whether they are or not. But if you say it long enough, then
pretty ambitious. Yeah, fair enough.
Become it. And there are very serious initiatives to again fund that. If you have aspiring entrepreneurs, students who see opportunities, who want to build a business around space data, mostly Earth observation applications, there's a lot of support. Go to the Satellite Applications Catapult, go to ESA BIC,
program through there as well.
Go to the people in Scotland who deal with that. And there's a lot of support, there's a lot of funding, and there's a lot of ideas and people who help you build a viable business around that concept. And those are the two pillars that I think the UK space sector is building on. But there seems to be a big focus on developing this independent, sovereign, perhaps, capability in the UK.
Yeah, there's a whole thing, isn't it?
But in this case, that's not necessarily a bad thing, because if I see the UK's is way ahead of the pack in as far as developing these spaceports is concerned. Whether it's maybe too many, do we need 8 spaceports in the UK, or could we do
as many as you can fit, really?
Well, at the moment, let them compete with each other, because that's how the market works, and let's see which one comes out a winner. But does it make sense? Yes, it absolutely makes sense, and
well, because like a couple more that I've seen as well, that like there's Black Arrow as well, that are trying to do like a sea launch.
Yeah, sea launch. Yeah.
As well. There's Blue Abyss as well, that are trying to do build an astronaut training center in the UK.
Yep.
So I mean, that's something that we want to look into in particular, is specifically astronaut training, because my metric is number of people in space. So like for all the upstream stuff that's going on and like all the CubeSats, it's like, okay, well, like that's step 1. Step 2 is like, how do we start getting more people up there?
Well, yeah, I mean, there's one way, and we've seen how that works, especially here in the UK, and that is, I mean, if you talk about human spaceflight, and I've not mentioned human spaceflight because human spaceflight is sort of a very small niche compared to this technology and this space data. Human spaceflight is a tiny element of the space industry. It's probably the sexiest and the most visible one in the eyes of most members of the public, but it is a tiny one. But if we see the effect that Tim Peake had when he went to the space station, and that was a costly operation for the UK government, is to get Tim Peake on the space station as one of the ESA astronauts, and as a one-off, because when Tim Peake came back, then that funding for human spaceflight in the UK became a lot less, and the attention went to the more profitable part of commercial space, and I actually think that's a good move. But what Tim Peake did is help the general public, the audience here in the UK, be much more supportive of space.
Well, why do you think human spaceflight isn't profitable? Like, what is stopping it from being like competitive, like with upscale, like upstream hardware?
Well, it's not a commercial endeavor at the moment yet. It's getting there very slowly, but it is easier to bring a small CubeSat into space, and cheaper and more affordable than to launch a heavy human into space.
It's like the difference between like 5 kilos and like 50 to 100.
Yeah, if you can squeeze yourself into a CubeSat, then suddenly it becomes a very viable business model. But I don't think you can, and neither can I. No matter how light I want to be.
That's it.
No, it's still at a different pay scale, if you like.
Yeah, it's almost like if this were like phase 1 or like phase like 1.5.
Yeah, and you know, and that's what you see in the transition from old space to new space is a government pioneers a certain area. It started with low Earth orbit, of course, and lunar exploration. That was all government for scientific, sometimes nationalistic reasons, but it was a government investment and purely government funded and government executed. Now that the government is really done with scientific exploration of low Earth orbit, it kind of makes it available to commercial players to start exploiting that. So it started with exploration, and exploration is a government task. There's no money to be made in exploration. But as soon as it reaches the exploitation phase, then it becomes interesting for commercial players and for entrepreneurs and people like you and me to jump in and make a living out of it. Small satellites is a way to do that. Space data is an even more accessible way because you don't need any investment. You just go to Sentinel Hub and download your data, and you build your business around that. So it's very accessible, very affordable. Human spaceflight is not there yet. You see companies like Axiom Space now trying to experiment with commercial flights, but it still needs lots of millionaires and billionaires to help them fund that. And
Yeah,
we're just
exactly.
not
It's
there
always
yet.
like the high, like this that whole business model, isn't it? It's like low volume, high value,
Yeah.
and then you use the money that you make from those kind of endeavors to build like medium volume, medium value, then high volume, low value.
Yeah, no, exactly. Because as soon as it becomes profitable to send miners to the moon to extract whatever they can extract there,
I mean, sign me
then
up.
it becomes interesting for commercial endeavors to start sending these very heavy bodies to the moon, which is a very big investment. But once it becomes profitable,
Interesting.
then it becomes accessible to commercial players. And at the moment, we're not there yet. That we're still 10, 15 years away from that. I'm sure.
Yeah, I was doing a rough back of the napkin calculation about in-space solar the other day, because like people talk about having solar panels on orbit that then you can wirelessly, well, because they're always in the sun if you put them in the right orbit, and you can wirelessly beam the power down to Earth.
Yep.
And that's being, I think JAXA, the Japanese Space Agency, is probably like the furthest ahead when it comes to that.
Yeah, I've seen Chinese initiatives. Interestingly, I've seen a UK initiative as well.
Yeah, but
university, it was presented at the Space to Connect conference in one of the closing speeches.
Sick.
I forgot exactly the name of it, but I'd never heard of it. But it was a UK study that was done for exactly that, with a massive installation, solar panels and capturing devices, and then beaming it down in radio waves or God knows how far.
But there's a prohibitive cost per kilo for those kind of systems to work. And this is the biggest thing about Starship, if and when it launches, is because for the amount of mass it can launch for the price of the ship, it makes a lot of projects like in-space solar, like going to the moon and mining specific materials and bringing them back to low Earth orbit, commercializing like low Earth orbit with people and with space stations. It crosses that threshold.
Yep.
So at the minute we're kind of limited by the launching hardware almost.
Yep. Yeah, no, absolutely, because the price per kilo into low Earth orbit or into higher orbits has remained, it's come down a little bit over the last years after coming down considerably, but now it's kind of stagnant, and we need breakthrough things. I mean, Falcon 9 was a breakthrough in that sense. That brought down the price per kilo quite significantly. That's why you see many launch operators and launch brokers now focusing on, for example, these transporter launches that SpaceX started last year. They're quite successful, launching hundreds of satellites in a single launch. But we need another breakthrough like Starship, because that will again bring down the launch cost per kilo to low Earth orbit.
I guess my question is, when it comes to Starship,
viable.
My biggest question when it comes to Starship, and this is kind of one of the primary things I wanted to talk about today, is that why is nobody trying to build something that competes?
Yeah, that's a good question. I don't know.
Because like I mean, it's all great, like pinning the hopes of a civilization on one man, which I think
No, I
is
think it's
inherently
ridiculous, but yeah,
problematic,
that's what's
right?
happening right now. Yeah.
Yeah, and it's like considering he's doing it all out in the open, I think probably with the intention of somebody copying what he's doing. Like what? Like what? How has it become the job of this billionaire when the relative investment? I mean, he said it yesterday in this presentation, is that the cost of Starship development so far has been 5 to 10% of the cost of building the Saturn V program.
Yeah.
So
No,
it should be
completely
accessible
understand that.
to governments.
Yeah, the thing is, what Musk is doing is not so much Musk. It is the brilliant people in SpaceX itself, um, that that have a completely different philosophy of developing these things. Where in the old days, in the 50s and 60s in NASA, it was all based on avoiding as much risk as possible. Elon Musk just destroys spaceships by the dozens.
Yeah,
It's a very different
it's a big
philosophy.
fireworks. Yeah,
So yeah, it's build, test, learn, and rebuild, and that's a philosophy that didn't exist in the 1950s and 1960s, and it's very much in line with how software development works nowadays compared to the 70s and 80s and 90s. It's much more agile. And why can Elon Musk do that? Well, first of all, because he is willing and able to take the financial risk, which is enormous, but he has built up his fortune. He can afford to do it, and there's very few people in the world that can do it. And he has hired the most brilliant people in the rocket industry. He has the best rocket scientists working on this around the clock, and he's willing to take also the technical risks involved there to do this. And the only other place where this is happening at the moment, I think, is in China,
yeah.
where
I mean,
they have
I
these
think
unlimited budgets and these extremely smart people, and the willingness to let things explode where maybe other governments would not want to be seen as wasting investment or wasting taxpayers' money by blowing up rockets.
Oh, I see. Yeah, that's an interesting point. I guess my reasoning for asking this in this way is that, like, I've always been saying, like, in the UK we have shipyards, we have we have the pedigree of designing submarines and best in class warships and all that kind of thing with the military. Like, how are we not able to apply that using like British steel and all this kind of thing, like play to the nationalistic kind of like the environment right now, but in a more like socially constructive way?
Yeah, and you know why? The way I see it, the way, like, for example, the Queen Elizabeth II, this new aircraft carrier was built.
Yeah,
They built it like the Saturn V. This is, yes, we have great heritage in British shipbuilding, especially up the Clyde and in the Portsmouth area. But these things are horribly expensive. This is old shipping, if you like,
yeah, it's
versus
like very well
the new
established.
philosophy.
Yeah,
And I mean, I don't know the shipping industry that well, but it's probably slower to adjust to new agile ways of developing stuff than the rocket industry is. And I don't think you can turn shipbuilders, especially since the peak of that heritage was in the 1960s and 1970s. I think it's too late to transfer that from building maritime ships to spaceships. I don't think that relationship is there. It's
maybe. I think. Well, I
technology.
mean, if you look at Starship right now, like the people that are building them, I mean, initially were people that build grain silos. The first tester
Yeah.
was a grain silo with a rocket engine on
Basically,
top of it.
yeah, no, that makes perfect sense. But yeah, I don't know how easy it is to transfer from shipbuilding to rocket building. I honestly don't know, but I don't think that relation is so clear. Besides, as I
There'll
said,
be like
most of that
it's almost like
knowledge.
you've got horizontal integration to vertical integration.
Yeah, I don't know if that's the big difference, but yeah, honestly, I don't know. But I don't see shipbuilding turning into spaceship building very easily. I think those are apples and oranges, really.
Maybe, okay, yeah, interesting.
I mean, even look for example at the automotive industry. How difficult is it for traditional car manufacturers to switch from combustion engines to electric engines? You would think, okay, the thing looks the same from the outside; it's just a different engine, but No. It doesn't
Under the
work like
surface,
that.
yeah, it doesn't work exactly the same, does it?
No.
The battery trays, they're having to like work out the weight distributions.
Yeah,
Um,
and that's just cars and future cars. So it's
but there are things like the high value manufacturing catapult, right? So speaking about the satellite applications catapult, there are many
yeah,
different types of catapult for different
sure. Yeah,
things
yeah,
like
yeah.
rail, like all kinds of things. But the
Yeah, there's
high value
9 of them, I
manufacturing
believe.
catapult,
Yeah.
it specializes in like super high tolerance, like automotive and aerospace.
Yeah.
Particularly more like for like Boeing and like large companies to like get like super high tolerance like machining done.
Hmm.
They're not really that accessible to the general like small businesses. Like I think
Yeah.
it's like £30,000 just to turn on the machines.
Hmm.
Like never mind any actual machining. So there maybe is like some kind of like overlap there, but I'm just trying to work out like, well, how
Well,
do
no, there
I
is,
put pressure on?
yeah, and let's turn it around and go back to the comparison of between the UK and other European countries. I mean, if the success of SpaceX can be copied anywhere in Europe, I'd say it is here in the UK, because there is this focus on high tech. I mean, we saw again, going back to London 2 weeks ago, Connect to Space. Minister Freeman, what's his name? George Freeman.
Yeah,
He was
George
there.
Freeman.
He was there, and the way he spoke about it, that the government, whatever you think of the current government, but the government is working on transforming the UK industry from a services-based industry to a science, engineering, and manufacturing, to a STEM industry, basically,
God damn,
is impressive.
It's about
And,
time.
and again, it's not just talk. That is what is happening right now
Mm.
with all these catapults. These catapults are a brilliant example. These catapults only exist in the UK. There are no equivalents in other countries that I know of that has so much focus on stimulating true technological innovation to help the economy of the country and to change the economy of the country towards doing exactly all those things that you say.
Well,
And
Mr.
if
Freeman is
any
an
country,
ex-venture capitalist, right?
yeah, if any country in Europe is able to start building starships anytime soon, it is the UK. Quicker than Germany, quicker than France, who are still stuck in old space, if you like, which is a big
Mm.
part of their economy. But
Well, I mean, ESA does a
they're
lot of good stuff.
transitioning, but
Just to
not
be
as
like,
fast as the UK is.
just to lay it out, I mean, I have huge respect for ESA, and like ESA does so much work across the entire continent, like for like making sure that there's development going on in all the different member states, that it's all
Absolutely.
coming
Yep.
together and integrated. It's just that they've almost like kind of fallen behind on the basis that they've stagnated on the way that they launch and how fast they can launch specific hardware.
Yeah, no, absolutely. But bear in mind that ESA, it's not the responsibility of ESA. ESA is government space, is old space, if you like, and they're very much focused on the exploration side and the exploitation side, just like what NASA is doing and what most space agencies, including the UK Space Agency, are doing. They leave the exploitation side to private industry, and ESA does the same. So much of the focus within ESA is on exploration, is on science missions, is on putting this government driven Earth observation infrastructure in place, and that's their role. The role of ESA, representing EU government or European government space, is really to facilitate that. One of the best things that ESA does, and I know the UK Space Agency does the same, is this whole focus on spin-offs and on making technology, making intellectual property, making expertise, knowledge available to the private market to commercialize this. That's why this business incubation center network in the UK, but also in the rest of Europe, is so critically important. And the good thing is that ESA puts a lot of money behind it as well. So there's funding available for people with good ideas on how to use this technology that ESA develops for exploration, to apply that to either other parts of space, to space exploitation, or to other parts of society. And that is really what a government entity like ESA should be doing, in my opinion. ESA should not be the organization that builds the European spaceship or Starship. That should be a commercial entity. It could be driven by ESA knowledge, and it could be funded through organizations like ESA, like the UK Space Agency, together with private funding, venture capitalists, very much like what SpaceX is doing. So supported by government money, but in essence being a commercial entity.
Okay, Remco, like I agree entirely. There's so much work that we could do here in the UK, and like there's the whole idea of like spinning out technologies is like so important for a lot of these small companies. But I appreciate like we're coming up towards the hour now,
Oh,
so
God, really?
I've taken
Oh,
quite a
yes.
lot of your time. Like if there were like one thing that you want to impress on the space industry globally, like based on like what you're seeing that maybe other people aren't seeing, what would that be?
Oh, that's very simple. Because I made that mistake quite a few years ago by thinking space is not for me. Space is far from my area of expertise or interest. It isn't. Nowadays, now more than ever, space is an integrated part of society that needs skills from a wide variety of backgrounds and people to function. So if ever there was a good time to join the space industry and to focus your career on space, it is now, because the opportunities have exploded over the last 5 years,
Yeah.
and there's a place in space for everyone.
I like that. I like that a lot. Remco, thank you so much for your time.
My
Like,
pleasure.
honestly, every time that we speak, I feel like it's like we're like progressing our understanding of like where things are going, and it's like it
I
feels
really hope so.
great.
It's just a brain dump. I can't believe the hour is over already.
Yeah, well, I mean, we could do it more than once if you want. I mean, I'd be happy to have you on again.
I'll gladly leave that up to you. I don't want to bore your audience.
No. Well, I mean, if they're bored, then I mean, they're secondary to this conversation.
Fair enough.
Good. Okay, fabulous. Well, thank you again, Remco.
Well, thank you very much for having me, Adam. It's always a pleasure to talk.
Brilliant. Thank you very much.